So I'll be showing the Grey's Anatomy pedigree for an Alzheimer's trait. Here's my key. A filled in circle means affected female, a filled in square means affected male, an open circle means unaffected female, and an open square means unaffected male. A circle with a question mark means unknown female, a square with a question mark means unknown male. So here's what we know so far from watching 16 seasons of Grey's Anatomy. In the pilot episode, we find out that Ellis Grey has early onset Alzheimer's and is in an assisted living facility. We also know that early onset Alzheimer's are caused by 3 single gene mutations, but for the purposes of this pedigree, we're going to be using the third, the PSEN2 on chromosome 1. So onto the pedigree. Ellis Grey was married to Thatcher Grey, and they had their daughter, Meredith. We know that at the end of season 9, Meredith gets tested and finds out that she has the Alzheimer's gene. But for right now, we'll put a question mark on her since we don't know if she will necessarily develop it. And here are some spoilers for season 10. Sorry if you haven't seen this far. Ellis Grey has an affair with Richard Webber and becomes pregnant. Their daughter is Maggie Pierce. We find out that Maggie got tested and that she has the Alzheimer's gene. She's unaffected as of now. So here is our full pedigree so far. We know that Meredith marries Derek Shepherd and they have 2 biological children, Bailey and Ellis. They do have a third child, Zola, but she is adopted, so sadly we're going to have to leave her out of this pedigree. We know that more than likely Meredith will pass on the Alzheimer's gene to Bailey and Ellis, but since they're so young, we don't know if they're affected or not. But we do know is that this type of Alzheimer's, the early onset Alzheimer's, is going to be autosomal dominant. So meaning that big A, or big A, little a will cause the person to have the gene. Meaning that even if Derek is little a, because we know Meredith has at least one big A, both Bailey and Ellis could be big A, little a, giving them the Alzheimer's gene. So let's check out modes of inheritance. Is it Y-linked? We can easily check this by looking at Derek and Bailey since fathers pass on the Y chromosome. Bailey is affected while Derek is not, so we know that it can't be Y-linked because of this. What about X-linked dominant? If we go ahead and fill in everybody's genotype, we could see that it would work out with the pedigree that we set up. So that would mean it could be X-linked dominant. But what about X-linked recessive? We can just fill in Richard, Ellis, and Maggie to tell that the inheritance doesn't work. To be affected, Maggie would need 2 little a's, and she has a big A, little a. Autosomal dominant? Again, by filling in everybody's genotype, we can see that everyone affected has a big A, which follows this mode of inheritance. So autosomal dominant works. Autosomal recessive, though. Again, by just looking at Richard, Ellis, and Maggie, we can see the mode of inheritance does not work.